So now we get to a lovely theory called the pure expectations theory. This theory assumes that investors establish bond prices and interest rates strictly on the basis of expectations about future interest rates. This means that they are indifferent with respect to maturity in the sense that they do not view long-term bonds as being riskier than short-term bonds. If this were true, then the maturity risk premium would be zero, and long-term interest rates would simply be a weighted average of current and expected future short-term interest rates. If the pure expectations theory is correct, you can use the yield curve to back out expected future interest rates. This is why I said earlier that it was really based on this pure expectations theory, that the shape of the yield curve tells you the expectations about future interest rates. If the yield curve is upward sloping, then market participants think that interest rates are going to increase in the future. If it's downward sloping, people expect interest rates to decrease in the future, and if it's flat, then people expect no change in interest rates for the future. And here is just a summary slide of what I was just talking about. So if you have different spot rates on different types of treasuries, if you have a 1-year, 2-year, 3-year, 4-year, 5-year, and you have the rates, you can use the expectations theory to figure out, or like we said, back out an implied forward rate. So the question here is, what does the market expect the interest rate on a 1-year security 1 year from now to be? And then what about a 3-year security 2 years from now? And since we have these rates right here, we can use a formula that's only available by using the pure expectations theory to figure these answers out. Here is just a simple example. So we used the rate on a 2-year spot rate on a 2-year treasury bond of 6.2% and the spot rate on a 1-year treasury, which was 6%. And by having these two rates, we can back into this X%, which is the implied forward rate 1 year from now. And a spot rate is what is observed in the market like right now, today. If we looked at the Bloomberg terminal today, what would we pull up as the current rates? And that's why I keep talking about spot rates. And so the formula is 1 plus the rate on a 2-year bond squared is equal to 1 plus the rate on a 1-year bond times 1 plus the rate on a 1-year bond 1 year from today. That's the X. And so you see, if you do the math, that you'll end up with X is equal to 6.4%, which is saying the rate on a 1-year bond 1 year from today should be 6.4%. And that would be higher than what we see for the rate on a 1-year bond exactly right now. This method is called bootstrapping. That's just another word for what we're doing. And really all we're doing is we're just saying that we should have the same amount of money if we invest in a 1-year bond at 6%, and then in 1 year we invest in another bond at 6.4%. We'll have the same dollar amount here at the end than if we would just have invested in a 2-year bond earning 6.2%. Would have the same amount of money here. So this next example was dealing with what is the implied forward rate on a 3-year bond 2 years from today. And so then the formula gets a little more complicated. So we look at the chart and find the spot rate on a 2-year bond and the spot rate on a 5-year bond. And then we're going to solve for this rate on a 3-year bond 2 years from today. And so then the equation is 1 plus, it's always the larger number where it goes out to 5 years, 1 plus the 5-year spot rate raised to the 5th power. So if it's this is a 5-year rate, it's raised to the 5th power. And that's equal to 1 plus the rate on a 2-year bond. And if that's a 2-year bond, we raise this to the 2nd power, times 1 plus the rate on a 3-year bond 2 years from today. And since this is a 3-year bond, we raise it to the 3rd power. And this just has to do with compounding. If it's a 5-year bond, it's like raising it to n, or compounding it 5 times. 2-year bond, compounding it 2 times. A 3-year bond, we're compounding it 3 times. And if we solve for the answer, we expect the rate on a 3-year bond 2 years from today to be 6.7%. And so you'd have to divide the 1.062 squared into the 1.065 to the 5th. And then you would have this right here. Next, you would have to raise both sides to the 1/3 power. And that way you could just have 1 plus x. And then when you subtract 1, you get the 6.7%. And then here's just like a summary slide for the author's conclusions about pure expectations. Well, the lenders prefer short-term securities and view long-term securities as riskier, so that would be support for having a maturity risk premium that's greater than 0. So the general conclusion is that there is a maturity risk premium. We want to describe now how macroeconomic factors affect the level of interest rates, and how do these factors explain why interest rates have been lower in recent years. So expected inflation, default risk, maturity risk, and liquidity concerns influence the level of interest rates over time and across different markets. Macroeconomic factors can influence one or more of these components. The primary factors are Federal Reserve policy, the federal budget deficit or surplus, foreign trade balance, and the level of business activity. The Fed controls the money supply and can stimulate the economy by increasing the money supply. Because the Fed buys and sells short-term securities, the initial impact is felt on short-term rates. Increasing the money supply would lower short-term rates. However, this might lead to an increase in expected future inflation, which would cause long-term rates to rise. Federal budget deficits must be covered by additional borrowing or by printing money. If the government borrows, this increases the demand for funds and pushes interest rates up. If the government prints money, the result will be increased inflation. The larger the foreign trade deficit, the more money the U.S. must borrow. Foreigners will only hold U.S. debt if and only if U.S. rates are competitive with rates in other countries. This interdependency limits the ability of the Fed to use monetary policy to control the level of interest rates. During recessions, short-term rates decline more sharply than longer-term rates. First, the Fed mainly operates in the short-term sector. Second, long-term rates reflect the average of expected inflation over 20 to 30 years, and this expectation generally doesn't change much. The Fed has been printing money, increasing the money supply, in other words. As a result, short-term rates are quite low. However, at some point, interest rates will rise due to inflationary pressure. And this is the end of the Chapter 6 PowerPoint.